Today, we're talking about a technology that sounds like it's straight out of science fiction. It's about creating a perfect digital copy of the physical world. We're talking about the digital twin. So get this, imagine a perfect virtual replica of a jet engine just humming away inside a computer. It's mirroring its real-world twin down to the tiniest vibration, the smallest change in temperature. Now, what if that digital copy could warn you that a critical part was about to fail, long before anyone could see or hear a problem? Well, that's not sci-fi. That's the core promise of the digital twin. All right, so how on earth is that even possible? Well, to really get it, we need to start with the fundamentals. So let's open our first chapter, the blueprint. At its heart, a digital twin is just a virtual model. But here's the thing, the magic isn't in the 3D model itself. The secret sauce is that it's continuously updated with real-time data. This means it's not some static, dead drawing. Nope, it's a living, breathing digital copy that mirrors the physical object's exact condition, moment by moment. Now, I know what you're thinking. Isn't that just a simulation? And that's a fair question. But there's a huge difference. A simulation, that's for playing out what-if scenarios in a make-believe world. A digital twin, though, is tethered to reality. It's always being fed real-time data. And here's the key, it can actually have a two-way conversation with the physical object. It doesn't just listen, it can talk back. And that whole idea of a two-way conversation, that's our bridge to the next chapter. A blueprint is just a drawing, right? It's lifeless until something animates it. So let's take a look at the nervous system that brings the digital twin to life. So think about it this way. If the 3D model is the skeleton, what makes up the nervous system and the brain? Well, for it to be a true functional twin, it needs two things. First, a constant stream of data. That's like its senses. And second, it needs an intelligence layer to actually make sense of all that information. So how does this data stream actually work? It's basically a 5-step loop that runs over and over, keeping the twin perfectly in sync. It all starts with collection. You've got these IoT sensors out there gathering data. Then that data gets transmitted and processed to make it useful. After that, it updates the virtual model itself. And finally, this new updated state is shown to a person or an AI who can then make a decision. This whole cycle just keeps repeating, making sure the digital version is always a perfect mirror of the real thing. And really, this whole thing boils down to two key pieces of tech. You've got the Internet of Things, or IoT. Think of that as the nervous system, the data backbone with all its sensors, constantly feeding information from the real world. But, data is just noise without a brain to understand it. And that's where artificial intelligence comes in. AI is the intelligence layer. It's the brain that analyzes all that data to spot patterns, predict what's going to happen next, and even learn as it goes. Okay, so we've got the blueprint and we've got the nervous system. Now let's head into the workshop and see what this thing can actually do in the real world. In the industrial world, the two biggest nightmares are things breaking down without warning and the supply chain getting totally tangled up. And this is exactly where digital twins become superheroes. They give you a way to see problems coming and test out solutions, all without ever having to hit the pause button on the real factory floor. And the solutions are honestly a game changer. We started with predicting when a machine might fail. That's predictive maintenance. But it goes so much further. You can use it to optimize the flow of an entire factory to get rid of bottlenecks. You can improve a product's design based on how it's actually performing in the wild. You can even stress test your whole supply chain to see how it would handle a disaster, all inside the computer. This quote from Forbes really just nails it. It's all about anticipation and optimization. By having this virtual playground where you can test and tweak and prepare for anything, companies can make their real-world operations faster, smarter, and way more resilient. But the impact of this tech goes way beyond just one factory or one supply chain. For our final chapter, let's zoom out to the entire ecosystem and see how digital twins are helping to power a more sustainable, circular future. So how in the world does a digital twin help us build a more sustainable planet? It all comes down to data. A circular economy, the idea where we reuse and recycle pretty much everything, needs the full story of a product, its condition, its materials, its entire life. The digital twin provides that story. Then another system called business intelligence, or BI, acts like the brain for the whole ecosystem, analyzing all that data to make smart choices about how we use our resources. And we're not just talking about some vague, feel-good concept here. When you actually combine the super detailed data from digital twins with the analytical power of BI, you get real, measurable results for sustainability. Take waste, for example. By putting these technologies together, studies show we could see a 27% reduction. Just stop and think about that. We could cut over a quarter of all industrial waste just by having the intelligence to know exactly where our resources are going and how to use them better. And it doesn't stop there. The same thing applies to energy. We're looking at a potential 32% drop in consumption. That's because you can fine-tune every single process, from a machine on the factory floor to a truck in the shipping network, to make sure not a single watt of power is wasted. But this number, this one is the real heart of the circular economy, a 45% increase in resource recovery. That means almost half the materials that we used to just throw away can now be recovered, reused, or recycled. This is how you close the loop. This is how you turn a wasteful system into a sustainable one. So, as we've seen, this whole journey of the digital twin, it starts as a simple blueprint of one single thing, but it evolves into something so much bigger. It becomes a cornerstone technology for building a smarter, more efficient, and truly sustainable world. And all of this leaves us with one last kind of mind-bending question to think about. As these digital copies become more and more perfect, as they get more deeply intertwined with their physical counterparts, constantly swapping data and influencing each other, where exactly is the line between the virtual and the real? And what happens when that line just disappears altogether?